Hello and welcome back. Here we are another day on this 6v6 amplifier and the fun continues. So yesterday I completely sort of redid the layout as recommended by some of the lads on the forum. The main thing I did was split the ground bus that was going all the way across here, basically joining the 6v6s. But I don't understand. Yes, this is what I've done in other amplifiers, but essentially they all go back to the power supply anyway, so I don't know really what I'm gaining there. Anyway, I think basically the idea was the less that all the stages have in common, the better our situation will be as regards crosstalk. However, I powered this up yesterday and we're still getting crosstalk. The other thing I've done, as recommended by a chap on the forum who's done some simulations in LT Spice, was not to put a coupling cap on the screen grids. Basically we had a 15k and a 10k decoupling the two screen grids, which were sort of basically coming off that one common source. With the screen grids at about 225 volts as per the datasheet. So he's gone for a different approach. He's gone for just like a 10k, and it did say 1k, but I didn't have any big 1k, so I just put a 1k5 in there, grid stopper. Both of the anodes to the 6SL7 are basically decoupled off the same sort of decoupling, which is how I had it in the first place. I've just sort of strapped two 10 microfarads together in parallel to give us 20 microfarads. That's a 6K8 dropper there. In a nutshell, the screen grids are running at a higher voltage and there's no decoupling on the screen grids, and we've got a, yes, I think the 6SL7 is running at a higher voltage. So everything's sort of running at a higher voltage, blah de blah de blah. And then what we're going to do, we're going to start it up in a minute and have a look. There's no decoupling capacitor on the screen grids. So let me power it up and let's have a look at some figures. So these are our DC conditions. The only sort of change, the big changes are, we've got a higher voltage on the 6SL7 cathode. That's because the cathode resistor that I've got in there isn't quite correct. Basically we've got a higher HT going into the 6SL7, so I should have changed the cathode resistor, so that's not really optimum, but we'll get back to that in a minute. The anodes are higher at 220. Big changes with the 6v6. The anode voltage is reasonably the same. Our screen grid, instead of being at 225-ish, 230, it's now at 286, and in the case of this one over here, the screen grid voltage is higher than the anode voltage, 294, 291. Also, as a consequence, our cathode voltage has gone up from about 12 volts to 16.4 and 15.6. And these are the figures I'm getting out. This is for an input of 500 millivolts, 1 kilohertz. Output maximum, I make it 4.2 volts RMS, 9.5% THD, and we're getting quite a bit of what do you call it on the screen grid, distortion. Let's have a look at the output first. Right, hold on, let me just, right, hold on. Right, this is the anode of the 6v6. It's about 3 volts, 3.4. You see there's some distortion. Yeah, distortion is about 10%. Not clipping though. No, it is. It is clipping. At about 4.9, this is saying on the HP 89, whatever it is. Yeah, 8903B. I was right. let's have a look at the screen grid. It's a good idea to discharge your probe. I'm just grounding that to chassis when you're taking voltage measurements, because in here, in this little vertical input plug-in, there's a capacitor blocking DC that gets charged up. So basically, when you take another high voltage measurement, the capacitor is already charged, say, to 200 volts, and you're sticking another 200 volts or whatever on top of that. It may exceed the maximum rating of your plug-in. Anyway, oh, the scope's on the scope probe, I've got it times 10. Right, just move my position. As you can see, there's a lot of distortion there. Rounding off at the top, pointing at the bottom. Right, so now let's turn this off and let's decouple that screen grid. So I've decoupled it with a big 220 microfarad 400 volt Nichicon cap, and that's decoupling it after this 10k resistor. Let's bring up the HT. I'm not really interested in the DC measurements just now. It's about right. Okay, now let's have a look at the screen grid. A lot of flattening, isn't there, straight away? Hold on. Well, that's about the same thing. I noticed that actually it's about the same, just a bit more rounding, isn't it? Let's have a look at the distortion of the output. It's gone from 10% to 5%. So the chap was saying, well, I don't know. Let's try the distortion right at a lower voltage. He was saying, the chap on forum was saying that basically our amplifier is going into clipping at about 2 watts. I know this HP 8903B can do watts, but I just never get round to it. So at about 3 volt, well, let's say 2.5. 2.5 volts RMS. See, we've got rounding of the screen grid. We've got 3.3% THD. I don't know if this is a very good idea to take this off, but what I'm going to do, I'm going to take off this decoupling and watch the distortion. That went up. And as you saw, our output went up of our screen grid. To my mind, I prefer, I don't know, let's go and have a look at all this on the spectrum analyzer and see what that tells us. Okay, as you can see, we've got a lot of harmonic distortion predominating with the second harmonic distortion here. Where are we? Our input's about 0.1 dB. That's at 0.01-ish. I don't know, it's a bit hard to say. Right, now then, let's bong that screen grid decoupling in. I don't know if we should do this on the move, as it were. It powered up. Okay, no big bangs, thank God. Right, that was at 2 volts RMS output. 2 volts are a mess. Okay, so what that's done, it's reduced the second harmonic distortion. And is that an increase in distortion full stop? A bit hard to tell, isn't it? Let's crank it all the way up to 4.2 volts, which is about the onset of clipping. Third is dominating. Right, let's take that screen grid decoupling off. See, the second shoots up. On, off, on, off. So what does all this prove? Do you know what? I've no idea. Oh, and we've still got the crosstalk problem. Let's not lose sight of that. I'll show you that on the scope. Like I say, I've tried everything. I've tried every suggestion, including that the what do you call it here? This big transformer is too near this 6SL7 here. I think basically this crosstalk is down to what is it down to? It's down to the sensitivity of the whole amplifier, I think. So let's pop that on the grid of the 6v6. Okay. And that's what we get on the grid of the 6v6 that hasn't got a signal to it. This is with the input ungrounded, and I'm now going to ground the input. Now then, that's at 2.6 VRMS out. As you can see, it's weird, isn't it? It's not a proper signal. Let's just not that. No, we won't do that. Yeah, so I don't know. I'm basically what I'm going to do. I'm going to listen to the amplifier instead of pissing about with it, messing about changing things. I'm going to go and have a listen to it and see what the crack is. Basically, Douglas Oaks says if our crosstalk is less than 20 dB, then it's not a problem. Let's see how many dB we got. Use the trusty HP, doodah blue bloop. Now we're in dB, minus 50 dB. So that's 10 dB. Okay, we're testing channel 2 now. We've got, with the volume turned all the way up, we're getting 7 millivolts out. So output, and this is the harmonic distortion. So I don't think it's going to be a problem with music playing through it, to be honest. So in which case I am going to apply some negative feedback, which I did yesterday. I'm not sure whether to decouple the screen grids or not. I think I'm not going to bother. I'm going to apply a bit of negative feedback and see what it sounds like, and then we'll leave it at that. So that's our output with some negative feedback applied. 2.3 volts RMS out, distortion 2.7, gone down a lot, hasn't it? We're applying quite a bit of feedback. And that's a harmonic distortion profile. Nothing really outstanding to say about that, only that the second dominates a little bit, but not particularly so. And all I'm using is a 3K3 resistor, just with a jump lead tacked in. We could use less, I don't know. I'm basically going to go and listen to it and then see what I think.
By the time that I'm through singing, the bells from the schools of walls will be ringing. More confusions, blood transfusions.
Well, I think that's the end of that one. I'm really surprised. It sounds really, really good. Just played a bit of love there. Forever Changes album, which is a really good album to audition music to, because it is, well, it's the best recorded album that I know of. Bruce Botnick was a friggin' genius. I mean, he did all the Doors albums. I think he did Pet Sounds as well by the Beach Boys. Real brilliant producer and engineer. Anyway, that crosstalk, it turns out I was worrying about nothing. I can't hear anything on the output at all. There's no hum on the output, so I solved that with the Alien Tin Hat. Overall, I'm very pleased with how the amplifiers turned out. Whether a discerning lady could carry it about to listen to music on the go, I've no idea. I shall give it to my daughter and see what she says, and let you know if indeed she does use it or just puts it in the corner like she has done with the record player that I gave her for Christmas. Anyway, thank you all for watching through this interminable series of the 6v6 amplifier build. We've had ups and downs, we've had a bit of swearing, we've had a bit of frustration, we've had toys thrown out the pram, but all in all, yeah, now I'm listening to it, it sounds really, 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 really good. And that's what it's all about, building Vogue amps. It's about listening to music, not about buggering about with test gear. Although that's sort of fun, it's not as good as listening to music. Anyway, I shall shut up waffling. Take care of yourselves. Ta-da for now.